So in this presentation, I'm going to cover two aspects of PYOTE. Bob has added a single point analysis tool for light curves that only have one point that look like an occultation. And then Roger, you mentioned that it would be nice to be able to know ahead of time whether or not we'll be able to even see an event. And that is what we do with PYOTE's event detectability tool. So I'll go over both of those. So the single point analysis that I'm going to cover, the data file is from George Viscomi that he gave to me. It was actually a valid 2-point event. There were 3 points, but 2 of them were transition. So the actual duration was approximately 2 points. And I just manually took it into Excel and revised it into a single point event for the sake of this demonstration. So I'm going to do 2 demonstrations with the single point tool. One's going to analyze that modified single point event, but at the full mag drop. And then I'll do a second demonstration on a different CSV file where I modified the single point to a reduced mag drop. So you can see the difference between those 2 processes. Okay. So now I want to stop that share. And I'm going to share my PYOTE screen. So now you should see my PYOTE screen, right?
Yes.
Okay. So we'll open the file. And here is the modified George Viscomi light curve. It's real light data from a real event, except that in this portion here, which you can see is a big drop, he actually had 2 transition dots and this bottom dot. So I just changed it to a single point so that we could look at that. We're going to use this tool right here called Validate a Potential Single Point Event. And if you right click on this button, you'll get a help screen that gives you the instructions on how to do this. And I'm going to demonstrate that to you. I won't read all of these instructions. But when in doubt with PYOTE or PyMovie, right click on the tool and read the help. It always helps. Okay, so say I want to just willy-nilly and click on this. PYOTE's going to trap an error that says you actually need to select baseline points and calculate statistics first. Go to the noise analysis tab to do this. So I would have known that if I would have read those instructions. So I'm going to go to the noise analysis detectability tab. And we're going to do a different function. We're going to analyze the noise in this light curve without the event in it. So we want to see if the noise will simulate this event or not. So we're going to create regions, which are baseline regions. And my baseline is not going to include the actual event. So I'm going to mark this region. And it turns the data points a kind of a beige. And I'm going to mark another region on the other side. And you can mark as many of these regions as you want. So if you have a cloud effect or something, you can mark around the cloud effects. So I marked the entire light curve except for the data point. And now I'm going to calculate the mean baseline and the baseline signal to noise. And you see that it also produces the correlated noise coefficients. And the correlated noise are the large up and down changes that occur in a standard light curve due to scene and scintillation and those things. So now that I've properly done that, I can mark my point with a red dot. I just left click on it. And now I can go back to analysis and I can click on this button, validate a potential single point event. And PYOTE analyzes the event to see if it would fall out of the distribution of possible single point events simply by noise. And it does. The right bar, the red bar falls to the right of the black bar. And the black bar is the point at which there are no single point events in 50,000 different trials of pure noise that are greater than the red bar. So we would say, yeah, that's a real event. Then because PYOTE methodology is statistically rigorous, Bob demands that there be at least 2 points in the bottom of an event to calculate the DNR times and the proper error bars.
Excuse me, Tony, because you're showing, well, the display of the distribution of points doesn't show because it's hidden. You know, it's that thing with Zoom. You really have to show your desktop, not a screen window.
Oh yeah, oh, I got you. I'll take care of that. But oh, that's correct. Yeah. Okay, I'll do that then.
You've got multiple windows open, so.
Yeah, I was trying to avoid that
Yeah.
whole thing here. So I'll do my whole screen. Share. Now you should see my whole screen. Is that correct?
Yeah, looks great.
Okay, so this is the graph that wasn't showing up. Sorry about that. Thank you, Bob. So this is the distribution of all single point events that would occur strictly due to noise equivalent to the noise that I measured in that baseline noise analysis. And our event clearly falls outside of that. So it would be considered a valid event. Now, so I was mentioning that PYOTE won't analyze this event because it doesn't analyze a single point event. But if you have a single point event that passes this test, you could report it as a valid event. You would report the time equivalent to this single point, realizing that you would report the start of frame time as the D part and the end of frame time as the R part. And I would report it with error bars of plus or minus half a frame. So that's how I do that. Any questions on that so far?
Yes, I just got one quick question. In this process, do you look at the light curves, any of the comparison stars, to make sure there's nothing similar with those stars?
Yeah, I could do that. Yeah, I could do that. So here's one. This would be George's event. So here's his single drop, and here's the tracking star, and there's no comparable event. I just skipped over that, Dave. Sorry. there's a lot and our timing is limited here. Okay, so so that was a valid single star event, but what if the drop wasn't quite as significant? So I'll look at that as my second demo. And what I've done is I've reduced the drop or increased the brightness of the single point. Okay, so I'm pretty sure I could probably, wouldn't have to do this over, but I'm going to. I'm going to reset all my points, mark my baseline. So if I right click, I get all the full width of the light curve. And then if I left click anywhere to the right side of the data points, it clicks on the last one. So now I've got them all marked. I'm going to calculate the baseline, which I've done down here. Same, it's going to be the same noise as before. But now when I go back and I say validate a single point event, I'll mark it. The red line is inside the black line. And so down below it says that was detected for validation, but the single point event is not valid because it has a non-zero chance of being due to noise. So even though your eye, and I would say, Richard, your eye is a very imprecise detector of events. Even so, your eye says, boy, that's an event. Statistics of noise tell you that there is a chance that random noise of the characteristics demonstrated by this light curve can generate that point when you do it 50,000 times and check all of the different points that are generated. So that's the risk that you take when you let your eye be your detector of an event as compared
So
to
is 50,000 the, there has to be 0 times out of 50,000 before it's considered no chance?
pardon, what was the question?
Is it 50,000? I've often wondered what that number is when they say 0 chance, because it depends on how many sigma you want to go out. You'll find some odds. But is it 1 chance in 50,000? That's enough to say that it's not a 0?
I believe it's it turns out to be around 4 sigma, 50,000.
4 sigma, okay.
Yeah, so it's great, a lot more than 3 sigma. We didn't get to 5 sigma just to save time, no calculation time. Okay, so that's the tool I wanted to demonstrate. Any more questions on that? Fairly straightforward.
Well,
And it works.
do we know, was that an actual event? Was there other observations?
Well, the actual event I analyzed was a true event. It passed the false positive. There was 3 data points in the light curve that were below the baseline. And I believe that George submitted it as a positive. I don't recall.
And
George?
it might be considered positive if there's another chord that has a definite event at the same time. So this doesn't necessarily, when it's called non-valid, it doesn't necessarily mean that it's non-valid. It may be verified by a simultaneous chord adjacent to it.
Well, that's true, but this is George Viscomi's chord, and it was a single observation chord. So yeah, I'm considering this as a single observation chord with a single point. Yeah,
Is that the same data, just smooth?
it's
Those
not
two very
smooth.
different-
No, it's just single data points. It's not smooth. There's no, I didn't change anything except I told you I took a 3-point event and turned it into a single point event.
Can I just comment that there are now a couple of events in our database which are based on a single point event. In the past, we've been quite relaxed if you've got 3 points at the same low light level, and 2 points, yes. But certainly I recollect we've got a single point event from Europe in the database. I have to say I am attracted to the approach that's been adopted or being put into peyote. Naturally, it's peyote to me, but like coyote. Just my Aussie way of thinking. But part of my concern and why I asked the question before is I think you need to make sure you look at other stars on the video to make sure there's no funny anomalies going on, and to make sure that there hasn't been some issue with the camera causing it. But I have to say I'm rather attracted to the approach, because when you've got a drop like that, it looks attractive as an event, but you do have to go through a process of being certain.
Yeah, it does. It looks like a real event, but if it was me, I wouldn't turn it in as a real event because it doesn't pass the test. So if it was my
Right.
observation and I ran this single event in PYOTE, you wouldn't see this particular event reported as a positive because it could be noise. It could be noise.
Yep, and it's the criteria for certainty comes in here. It's a challenging issue, and when you take a look at the statistics of, let's say you've got an event which has a duration of say 1 second, and you're recording at frame rate. What is the probability of you getting a 1 frame duration occultation? It's a very, very low probability because you have to be right on the edge of the path. It's a very narrow band where you get a single chord event. So, yeah, generally I like to see the characteristic of a light curve, which is sudden drop, flat bottom, sudden rise.
Yeah, you might suggest to Eric that if they submitted a single point from Europe, that they run it through this test and see if it would pass it. Would be a good exercise.
Yeah, certainly with that particular one, we had a lot of discussion, and yeah.
Okay, so I'm going to move on to the next one.
Hey, Tony, this is George. The one factor in there, first of all, Zoom booted me off, so I didn't see the first part of your presentation.